Hello friends, welcome back. In this video, we are going to study the remaining terms involved in coordination chemistry. So this is the coordination chemistry part 3. So let's start with this. So the next term that we have to study is the ligand. Okay. So we are known with this, the ligands. Ligands, they are the coordinating groups. So the groups which are attached to the central metal atom while forming the coordination compounds are known as the ligands. So let's see the definition. Any atom, ion or molecule which is capable of donating a pair of electrons to the central metal atom or the ion is known as the ligand, which is also known as the coordinating group or which is also known as the Lewis base. Now in this we can say that in a ligand, a particular atom which donates the electron pair is called as the donor atom or which is also called as the donor site, right? Then we can say that the example of the ligands. So the example of the ligand is NaH2O6. Now here we can say that this sodium is a central metal atom and it is surrounded by the 6 coordinating groups, 6 coordinating waters. So these 6 waters, they are known as the ligands. So let's see the structure. So we are having at the center a sodium, that is central metal atom, and it is surrounded by the 6 coordinating groups, that means the 6 ligands, and each ligand, that is the H2O ligand, is having the oxygen atom, and this oxygen atom, they are having the extra electron pair, that is known as the lone pair, and that lone pair is donated by the oxygen to the sodium. That's why there is a formation of the dative or the coordinate bond. In this way, there are 6 coordinative bond formed between the 6 oxygen and the sodium, that is the central metal atom or the ion. So here we can say that this is the first water ligand, second ligand, third ligand, fourth ligand, fifth ligand, and the sixth ligand. So in this way, there are the 6 ligands or the 6 coordinating groups attached to the central metal atom sodium. So let's see the ball and stick model of the same structure. So this is the ball and stick model of the NaH2O6. So at the center we are having the sodium metal and it is surrounded by the 6 coordinating groups or the ligand, that is the water ligand, and in which there is a coordinate or the dative bond formation between the oxygen and the central sodium. So this is regarding the ligand. Further, we can say that there are the types of the ligands. So depending upon the donor atom means which is donating an electron pair. So depending upon the donor atom or the donor site, or we can say that depending upon the number of donor atoms or the coordinating groups present in the ligands are classified as, the first one is the monodentate or the unidentate ligands. The second type is bidentate ligands. The third type is tridentate ligands. The fourth type is tetradentate ligands. The fifth type is pentadentate ligands. Sixth type is hexadentate ligands. Or finally, we can say that the seventh type is polydentate ligand. So depending upon the number of donor atoms, so how many donor atoms are present in a particular compound, depending upon that we are having these types of the ligands. Let's study each type one by one. So first of all, the first type is the monodentate, or it is also called as the unidentate ligands. Now when there is a single donor atom in a compound which is forming the coordinate or the dative bond, then that type of the ligands, they are called as the monodentate or the unidentate ligands. So the definition is, if a ligand contains only one donor atom that is capable of forming only one coordinate bond to the central metal atom or the ion, then the ligand is called as the monodentate or it is also called as the unidentate ligand. Now its examples of this. The first type of examples which are monoatomic halide ions, that means the F minus, Cl minus, Br minus and the I minus. Second type of examples are the polyatomic ions such as Cn minus, SCN minus, NO2 minus. Then positively charged species such as N2H5 plus, NH2, NH3 plus. And a fourth type of example is the neutral molecules such as the NH3, that is the ammonia, and the H2O. So these are the examples of the monodentate or the unidentate ligands in which there is a single donor atom. Means there is only one atom which is donating its an electron pair. So we can say that this type of ligands may be the positive ions, they may be the negative ions, or they are the neutral molecules. So let's see further. The unidentate ligands may simultaneously coordinate with two or more metal atoms. That means single ligand is coordinated to two or more metal atoms. Such type of ligands, they are called as the bridging ligand. They are forming a bridge. That's why they are called as the bridging ligand. And the compound thus form are known as the bridge complex. Right. So let's see an example. Its example is this one. Now here we can say that the chlorides, they are the ligands. Now this single chloride, it is linked to one side fluorine and also to the another side fluorine. Also we can see this chlorine, it is attached to one fluorine and the one Fe and the another Fe. So in this way, the single ligand simultaneously coordinate to two metal atoms. So that's why this type of the ligands, they are called as the bridging ligands, and the complexes, they are known as the bridge complex. Okay, so this is regarding the monodentate or the unidentate ligand. So let's see the examples of the monodentate or the unidentate ligands. So the examples are, the most commonly used examples are the water, ammonia, and the pyridine. Their symbols are, for the water, we used to write aqua. For the ammonia, amine, and for the pyridine, we have to write the Py. So let's see their structures. Now for the water, we are having the H2O, and there is a bond formation between the oxygen, and here there is a metal. So there is a coordinated bond formation between the oxygen and the metal, and the arrowhead is from donor, that is oxygen, to the metal. In the second example, that is the ammonia, that is NH3. Again the lone pair is on the nitrogen, that means there is a bond formation between the nitrogen and the metal. Third example, pyridine. Pyridine means a benzene ring is attached to nitrogen. That means there is a dative bond formation between the nitrogen and the metal. So these are the three examples of the monodentate or the unidentate ligands. Now bidentate ligands. Now as the name suggests, bidentate means it consists of two donor atoms or the sides. So this type of ligands contains two donor atoms. So their examples are, the three examples that we have to study are the ethylene diamine, 2,2-dipyridyl, and the third one is the glycine atom. Then the symbols. The symbol for the ethylene diamine is En. Instead of writing this full name, we have to use only En, and En means ethylene diamine. Then for 2,2-dipyridyl, we have to use the symbol dipy, means dipyridyl. And third, for the glycine atom, we have to write the symbol Gly. Gly means the glycine atom. Now from these symbols, we can find out the ligands. Now let's see their structures. For the ethylene diamine, ethylene means the CH2CH2 group. So this is the CH2CH2 group, and diamine means 2NH2 group. So this CH2CH2 at one side attached to one NH2, another side attached to one NH2. So it is ethylene diamine. Now here there are two nitrogen atoms. Two nitrogen means two lone pairs, and they are donated to the metal. So here there is a metal, and as there are two donor atoms, it is called as the bidentate ligand. Then the second, that is the 2,2-dipyridyl. Pyridyl means the pyridine. Pyridine means the benzene ring is attached to nitrogen. So we are having, this is the first benzene ring which is attached to nitrogen, or this is the first pyridine, this is the second pyridine. Now if you give numbering, numbering is starting from the nitrogen. So this is the first, second, third, fourth, fifth, and the sixth, right? This is the one pyridine. Another side, for the nitrogen, it is 1-, 2-, 3-, 4-, 5-, 6 dash. So this position is the 2 and this position is the 2 dash. So it is called as the 2 dash dipyridine, right? Now here there are two nitrogen atoms, that means two donor atoms. That's why it is a bidentate ligand. They are forming the dative bond with the metal atom. Third example, glycine atom. So glycine atom, in the glycine atom, it is having the structure NH2, CH2, COO negative. Again, nitrogen and oxygen both are having the lone pair of electron. They are forming the dative or the coordinate bond with the metal. That's why we can say that it is an example of a bidentate ligand because it is having the two donor atoms. Then, third type, this bidentate ligands having more examples. They are 1,10-phenanthroline and acetyl acetonato. So their symbols are, for the 1,10-phenanthroline we are having the symbol phen, and for acetyl acetonato we are having the symbol ACAC. So let's see their structures. For the phen means 1,10-phenanthroline. So this is the structure of 1,10-phenanthroline. Now here there are two nitrogen atoms, that means two donor atoms. That's why it is an example of bidentate ligand. They are forming the coordinate bond to the central metal atom. Now how it is 1,10-phenanthroline? So this is the nitrogen with atomic number with the number 1. So this is 1, 2, 3, 4. Then 5, 6, 7, 8, 9 and 10. So it is 1,10-phenanthroline. Next one is acetyl acetonato, right? That means acetyl group means, what is the acetyl group? Acetyl group is the CH3CO group, and acetonato means it is an acetone. Acetone is CH3 C double bond O CH3. So this is the acetone and this is the acetyl groups. So both they are a link, therefore it is called as the acetyl acetonato, which is having symbol ACAC. Now here there are two oxygen atoms, both are having the lone pair of electron. They are forming the dative or the coordinate bond with the metal. That's why it is an example of the bidentate ligand. One more examples. They are a dimethyl glyoxymato and the oxalato. So their symbols are, for the dimethyl glyoxymato we are having symbol DMG, and for the oxalato we are having the symbol OX. So their structures, for the DMG, that means that it is a derivative of dimethyl glyoxime. So it is again having the two nitrogen atoms which are having the lone pair. They are forming the dative bond or the coordinate bond. That's why it is an example of the bidentate ligand. Oxalato. What is the oxalato? Oxalato is a derivative of oxalic acid. Oxalic acid, that is COOH, is linked to COOH. That means there are two oxygen atoms which are having the lone pair. They are forming the coordinate or the dative bond with the central metal atom or the ion. That's why it is an example of bidentate ligand. So these are the various examples of the bidentate ligands which are having the two donor atoms. Then tridentate ligands. Again the name suggests tridentate ligands means they are having the three donor atoms, or they consist of three donor sites. So these type of ligands contains three donor atoms. So their examples are diethylene triamine, and the second example is 2,2-terpyridine. Okay. So the symbols. So symbol for the first, that is a diethylene triamine, is DIEN, and for the second one is the terpy. Okay. Then the structures. DIEN means the diethylene triamine. Di means two, ethylene means two ethylene. So this is the first ethylene CH2. This is the second ethylene CH2. And tri means three amines. So this is the first amine, this is the second amine, and this is the third amine, right? They are a link, therefore we are getting the formation of diethylene triamine. Now there are three nitrogen atoms, that means three lone pairs. They are forming the coordinate or the dative bond with the central metal. Now here there is a metal. So this is an example of tridentate ligand. Second example is a 2,2 2 double dash terpyridine. So its structure is like this. That means there are 3 pyridine rings. They are a link at the 2 positions, right? Now we are having the 3 nitrogen atoms. That's why 3 lone pairs. That's why 3 coordinating or the coordinative bond or the dative bonds, and which is formed with the central metal. So here we are having the metal. So this is the position 2. This position is known as the 2 dash position, and this position is known as the 2 double dash position. So this is the structure for the TER-PY. Next type of the ligand is a tetradentate ligand. Means they consist of 4 donor atoms or the 4 donor sites. So this type of ligands contains 4 donor atoms. Their examples are triethylene triamine, which is having the symbol tri-En. Triethylene means it is having 3 CH2CH2 group, and the triamine means 3 NH2 group. Okay, so its structure is like this. So 3-ethylene means this is the first ethylene, CH2CH2, this is the second ethylene, and this is the fourth ethylene. And then it is having 4 amines. So this is the first amine, this is the second amine, this is the third amine, and this is the fourth amine. So there are 4 nitrogen atoms. That's why they are having the 4 lone pair. 4 lone pair means 4 coordinative or the dative bond, and it is formed with the central metal atom or the ion. Okay. So here instead of triethylene triamine, it is here triethylene tetra. Tetra means 4. Here there is not tri, it is tetramine. So triethylene groups and the 4 amine groups. It is example of the tetradentate ligand because it is having the 4 donor atoms. Then pentadentate ligands means they are having the 5 donor atoms or the 5 donor sites. Its example is ethylene diamine triacetato. So this is the structure of ethylene diamine triacetato. Ethylene means, what is ethylene? Ethylene is the CH2CH2 group. Diamine means 2 NH2 groups. And triacetato. Tri means 3, acetato means CH3COOH group. Okay. So ethylene means this is a CH2CH2 group, right? Diamine means 2 nitrogens, 2 NH2 group. So this is the first NH2 and this is the second NH2. And they are attached to the triacetato. Acetato, that is a CH2COO. So this is the first acetato. Then CH2COO. This one is the second acetato. Then CH2COO. This is the third acetato. So in this way, when they are a link, we can see that there are first, second, third, fourth, and the fifth. 5 donor atoms. There are 5 lone pairs which are forming the coordinate or the dative bond with the central metal atom or the ion. That's why it is an example of the pentadentate ligand. Okay. Next, hexadentate ligand. Hexadentate ligand means it consists of 6 donor atoms. So this type of ligand contains 6 donor atoms. Its example is the ethylene diamine tetraacetato, that is EDTA. So what is the structure of the EDTA? Ethylene means CH2CH2 group. So at the center we are having the CH2CH2 group. Diamine means 2 NH2 group. So this is the first NH2, this is the second NH2. So this is the ethylene diamine. Tetra means 4. Acetato means 4 acetic acid. Acetic acid is CH3COOH. So 4 acetic acid groups, they are attached to the 4 bonds of the nitrogen. So this is the first one, that is CH2COO negative. CH2COO negative, this is second. CH2COO negative third. CH2COO negative fourth. So this is the structure of the EDTA. So this EDTA, that is the ethylene diamine tetraacetato, it consists of 6 donor atoms. So this is the structure. We are having, this is the ethylene diamine, ethylene group, right? CH2CH2 group. Diamine means 2 nitrogens. right? Diamine. Tetra means 4. Acetato, that means acetic acid. So this is the CH2COO negative, that is the first one, CH2COO. This is the second, CH2COO. This is the third, CH2COO. This is the fourth. So in this way there is 1, 2, 3, 4, 5, 6. 6 donor atoms, therefore 6 lone pairs. That's why 6 coordinate or the dative bond with the central metal atom or the ion. Hence it is an example of the hexadentate ligand. And last, polydentate ligands. For the polydentate ligands, we can say that this type of ligands contains more than one donor atom per molecule. Means for a single molecule, there are more than one donor atoms. So in polydentate ligands, if two or more donor atoms coordinate by the simultaneous use of two or more electron pairs to the same metal atom, the ligand is then called as the chelating ligands. That means in a single ligand, there are more than one donor atoms. And when they are coordinated to the same central metal atom or the ion, then it is called as the chelating ligand. And the complex thus form is known as the chelate. Okay. So let's see an example. Its example is MNH2CH2CH2NH2 thrice 3 plus. Now this is the ligand NH2CH2CH2NH2. Now here there are two donor atoms, two nitrogen atoms, they are donor and they are linked to the metal. Therefore it is called as the chelating ligand and the complex is called as the chelate. So here we can say that metal M is the trivalent metal ion because it is having the 3 plus charge. So this is the structure. Here we can say that at the center we are having the metal and it is surrounded by 3 ligands. And the 3 ligands, they are having the 2 donor atoms, 2 nitrogen atoms and they are linked to the metal. So we are having NH2CH2CH2NH2. This is the first ligand. NH2CH2CH2NH2. This is the second ligand. NH2CH2CH2NH2. This is the third ligand. So there are 3 ligands but the bond forms are the 6. So these type of compounds, they are known as the chelates and the ligands, they are known as the chelating ligands. Hence, these are the examples. This is the first example of the chelating ligands or the chelates. So here we can say that at the center we are having the metal and this metal, it is surrounded by the 3 ligands and each ligand is having the 2 donor atoms, right? These are the 2 donor atoms and they are coordinated to the central metal ions. Therefore, this COEN thrice 3 plus is an example of the chelate. Second example of the chelate is COEDTA minus. Again, we are having at the center a cobalt metal and it is surrounded by the ligands. And each ligand consists of the oxygen and the nitrogen, 2 donor atoms and they are linked to the central metal. So this COEDTA is again an example of the chelate and the ligands, they are known as the chelating ligands. So let's see the comparison between the metal complex and the metal chelate. So at one side we are having the metal complex and another side we are having the metal chelate. So the metal complexes, the monodentate ligands forms metal complexes and such ligands are called as the complex agents. That means the metal complexes, they are formed by the monodentate ligands. Whereas the polydentate ligands forms the metal chelates and such ligands are called as the chelating ligands. In case of the metal complexes, the heterocyclic rings is not formed and hence these are the non-cyclic compounds. Whereas in case of the metal chelates, the heterocyclic ring is always formed and hence these are the cyclic compounds. Its example of the metal complex is CuNH3 2 plus. Whereas for the metal chelate it is CuEn twice 2 plus. So this is the structure of CuNH3 2 plus. Here we can say that the copper at the central metal iron and it is surrounded by the 4 NH3. These ligands, they consist of the single donor atom, right? So it is a monodentate ligand. Whereas for the CuEn twice 2 plus, at the center we are having the copper, a metal, and it is surrounded by the 2 ligands. And each ligand consists of 2 donor atoms, 2 nitrogen, which are the donor atom. That's why it is an example of the metal chelate. Again, in case of the metal complex, we can say that they are moderately stable. Whereas the metal chelates, they are highly stable because they are having the more number of donor atom per ligand. So this is the difference between the metal complex and the metal chelate. So thank you. Here we are completed with the terms involved in the coordination chemistry. Thank you.